Okay, right. I'm just going to say a few words then, just to kick off and give people a bit of background, and then I'll hand over to Matt, who's going to introduce Roberto. So, well, for those of you that don't know me, my name is Barry Cranford. I'm actually the founder of the London Java community. I'm not a developer myself. I run a tech recruitment company called RecWorks. So here at RecWorks, we're on a mission. And have been for about the last 12 years to prove that recruitment can be a force for good in the tech industry, beyond just getting people jobs. For example, a few things that we really try to focus on are learning, mentoring, career development. Put simply, if people want to learn and people are happy to share, then we're happy to make the connections, and that can be on a group basis, like this evening, on a one-to-one level. So a lot of the work we do is based through the Meet and Mentor community, which has got really close links with the LJC. I know a few of you coming on tonight are members. We've made about 2,500 introductions through there now, and I think we've got about 1,700 members. So we're always looking for more mentors. So if anybody is interested, anyone's open to helping out, either students, engineers, junior CTOs, anybody that you're happy to help, then please do give us a shout. It's all powered by recruitment though, so we don't make any money from anything else, only through getting people jobs. So if anyone's looking, then again, please do bear us in mind. Anyway, I'm going to hand over to my co-host now, Matt Nichols, who is a member of Meet and Mentor, and he is going to introduce our speaker, Roberto. So I hope you all have a great evening. Thanks. Matt, I think you might be on mute there, mate.
Apologies. Hi, everyone. Sorry, there was a mute problem there. So so I'm Matthew Nichols. I'm a principal Java developer, but obviously we're here today to hear Roberto Cortez talk. So Roberto has about 10 years experience as a Java developer, which he's very passionate about. He's actually heavily involved in the open source community, and he's also very passionate about helping other individuals. So help individuals spread their knowledge about Java technologies. So he's actually a regular speaker in other conferences such as JavaOne, DevOX, DevNexus, JFocus, and some others. He leads the Quimbran Jug. I have no idea what that is, but and founded the J Nation conference in Portugal. So pretty impressive. And obviously we're all software engineers, but we also do have lives outside of software. So in his spare time, Roberto is like hanging out with his friends, playing some games, and spending some time with his family. So that's the introductions done. So Roberto, please tell us about Quarkus.
Hi, yeah, thank you so much for having me here today. It's really grateful to be here with the London Java community. I usually go to London every year to present a session at DevOps UK. I actually had this session to present over there, but well, unfortunately it was cancelled due to the pandemic that we're living. So I'm really grateful that I'm able to do that remotely for you guys. Well, I hope everyone is safe. And hope that everything improves in the next couple of months. So maybe we can schedule something in person, and I can go there and present something to you. Okay, so without any further delays, so thank you again for the introduction. I'm gonna talk a little bit about Quarkus today. So I'm gonna do just a really small disclaimer, which was most of the work that or actually all the work I'm going to present here today, it was when I was not working with Red Hat. So right now I might be a little bit biased because I actually joined Red Hat and I'm working in Quarkus directly. But this was the story about me working in a consultant company, adopting Quarkus, and the things that me and my team found out about that story, and then coming up and running Quarkus in a production environment. Just want to make that disclaimer because yes, I might be a little bit biased now because I'm working with the team that develops Quarkus, but what we have done here today was not when I was at that team. Okay, so let me share that screen a little bit. I'm gonna do a couple of slides, and then most of it's gonna be demos. So feel free to interrupt me anytime to post any questions. I usually like the sessions to be interactive, as most interactive as possible. So if you see any questions, see something that you want to ask me about, just interrupt me. I'll be happy to answer it. Okay, so let me share the screen. Okay, so I think I have an issue because, okay, give me a sec. I think so. This is a new Mac, and I believe that I don't have the privacy security for sharing screen with Zoom. So most likely gonna have to reconnect again. Is that possible?
Yeah, should be fine.
Yeah, okay. So give me a sec. I'll have to restart Zoom so I can be able to allow share screen with Mac. So be right back.
In this time, then, just to fill the gap, I'll have a chat with you guys. I don't know if you've if anybody's seen this, but we've started an aspiring speakers group in London. So if anybody is interested in getting involved on and giving some lightning talks or full conference talks or anything, then do let me know. See me on LinkedIn. How you looking, Roberto?
Okay, yeah, so I should have permissions now. Now you just need to allow me to share myself.
Yeah, got to put you as co-host again. Hold on one sec.
Okay. Okay, now that should that should work. Yeah, sorry about that. So that was like this is like a new Mac, so I haven't been sharing the screen too much on Zoom. So so I'm guessing that everyone's able to see my screen, right?
Yeah.
And let me put that as full screen. Okay, so this presentation is also I've done this presentation in a couple of other conferences, and also Bruno Batista was a colleague that was working with me at the time at the company. We were developing this. He's still over there, and he was. We were working both on this together. So a lot of the presentation, a lot of the code that we wrote is also on him. Okay, so for agenda for today, we're gonna talk a little bit about Quarkus, of course, and why we ended up choosing Quarkus for what we wanted to develop. I'm gonna show a lot of demos around the things that we were working on how Quarkus we can write Quarkus applications to meet your needs, and hopefully then I'll share some of our ideas and our thoughts on our adoption story since we started our experience with Quarkus at that time. So okay, Quarkus, right? So if you usually when you want to learn about something, of course you go to the web page, and when you go to the Quarkus web page, you're usually going to see things like that, like saying that supersonic subatomic Java, which is container first, imperative and reactive programming models, and it is developer friendly. But what actually means those terms? So those are big terms, right? Other platforms might do something very similar. So especially all of them want to be developer friendly. But Quarkus does offer a couple of interesting things that we're now starting to see in other frameworks showing up. But maybe when Quarkus came out a year ago or 1.5 years ago, that's where when we started really looking into it, it was offering very interesting things, right? Which are still there, and they really improve the developer experience when you're building an app, right? And that's what you usually want when you're starting something fresh, or you want to migrate something, right? You want to have pleasure on what you're doing. And I believe that you can achieve something like that with Quarkus, right? So one interesting thing about Quarkus is we call Quarkus a full stack, and we call it full stack because most likely you recognize some of these logos, or if not all logos that are here, right? So we have things like Hibernate, Camel, MicroProfile, Kubernetes, Jaeger, Kafka, REST Easy, so and more. So these are some of the most well-known frameworks and tools and libraries that are shipping with Quarkus. But there are way more, and we're getting more every week. So it is interesting because when Quarkus came out, and on the, I know there we have some people from human resources over here, right? And then usually they ask if they have like 5 or 6 years of experience with Quarkus, or when something new comes out, and you actually have, right? Because when you look into Quarkus, Quarkus is not actually new. So what's new is actually the glue codes around those libraries, those frameworks. But the stack that you use to develop applications has been around for several years. So probably most of you already, or at least heard about Hibernate, or maybe develop an Hibernate application, right? All of you probably are developing REST applications using JAX-RS or Spring MVC or Spring Webflow, right? Which Quarkus also supports. So when you look, and when I show you a couple of code samples about Quarkus, probably not going to see anything new, right? On the code side. But Quarkus itself is tailored for some of the new paradigms, especially when we're trying to deploy stuff into the cloud, or trying to stuff things into containers. Well, Quarkus does help a lot in that regard, right? And we're going to see why. So some of the requirements that we have when we wanted to build these applications, so to make it a little bit more clear, so this company, they was trying to make a couple of new products, right? They already have products that they were developing using Kotlin and Spring. And me and some of my team were tasked to come up with the technology that we're going to use for these new products. So of course, Kotlin and Spring were the main containers at that time, and that probably they still are, right? So it's because they're super popular. But we also wanted to have a look into things that were coming out, right? And especially if you're trying to do something new that might not have too much impact on your organization, it gives you the perfect opportunity to try out new stuff and see if that goes, instead of you just being locked into the same old technology all the time. So for our requirements, we have, of course, we wanted to support microservice architectures. I mean, Quarkus does really a good job in this regard, but it's not really mandatory. So you can build a monolith with Quarkus as well. And for any other platform that does support microservices, you can do whatever you want with it. So it's not really a big deal. But one thing that we really wanted to support was cloud deployment. So all this company has all their hardware and all their software running on the cloud. So that was a mandatory for us. We really wanted to do it. We also wanted to have a polyglot environment. So a lot of the things that we're going to develop were data science related and mathematics related. So we have data scientists with us, and usually, as you probably know, they don't like to code Java that much. They like to do their stuff in other languages like R or Python. So of course, we wanted to support those languages and those environments as well. And we came up with a pretty good idea to how to do it using GraalVM and Quarkus. And I'm going to show you a couple of samples on that as well. And yes, we wanted to have the platform that we're developing to be event-driven. So the idea is that any action that will happen on the application will just generate events, right? And then you have other services consuming those events. So this will ensure that the application will be highly scalable, and also that you wouldn't have direct dependencies between your services. So you could basically put them out up and down and just develop them completely in an isolated manner, and then just assemble them into a full platform. So a couple of other requirements that we had. So we have multiple services that we wanted to deploy. So at the start, we wanted to develop like 3 or 4. Currently, I know that the team has maybe like 10, 11 or 12. Don't know for sure, but they of course have been growing in the services number. Some of those, of course, are long-running processes, so which the JVM really shines. But most of those processes were pretty much like picking up some random data, processing that data, and then outputting a couple of values. So of course we wanted to have some data pipelines that were executed asynchronously. So right now I know that they're processing a good amount of chunks of data. So we're talking about millions of records per day. So I'm not sure how it's going to evolve in the future, but at least the system is holding for now. So hopefully it will be holding in the future when you have to keep processing way more. So part of our process was also look into other alternatives than Quarkus. So Quarkus didn't came out. We just didn't pick Quarkus just because, right? So we took a couple of weeks off, and then we picked like a simple service. We prototyped that service into some of these platforms, of course, Spring Boot, which we already had some experience with, Micronaut, Dropwizard, Legume, and a few more. And after the prototype, of course, we prototyped that in Quarkus as well, and then we just compare some strengths and weaknesses, and we end up deciding going with Quarkus. So I'm not going to focus too much on the ups and downs on Quarkus versus all these other platforms, because I don't want to enter into a war in Quarkus versus something else. I just want to focus on what we thought that was cool on Quarkus and what we didn't like on Quarkus. So then you know what you can expect, and then maybe you have a couple very nice idea if you want to adopt it in the future and to compare it with other platforms. And of course, you know, sometimes there is some biases in the teams, and depending on your requirements, maybe some other platform is more suited to whatever you want to do. So I don't really want to be biased here with that. So regarding Quarkus, so why we end up picking Quarkus? So yes, so the support for microservices was really out of the box, right? So me and my team, we also had developing a lot of things using technologies like MicroProfile, which, if you haven't heard about that before, is a new initiative. Well, it is a couple of years old right now, but basically the idea is that it's trying to bring standard specifications to help Java developers build microservices. And then you have people like Red Hat, Microsoft, Oracle, Atomic Tribe, IBM, Payara involved into doing those specifications. So it's quite interesting in that regard. A native mode, so probably heard about Quarkus native mode. The idea is that when you can build your application as native, and then it will start really quick, and the memory usage is going to be really small. So this, of course, was really interesting for us, because since we were running everything on the cloud, if we could save some costs on our cloud usages by lowering the resource consumption of our services, of course, that will be awesome because it will just be saving some money for the company. Then GraalVM. So a lot of you probably heard about GraalVM, and GraalVM is the secret behind the native mode, right? But one of the things that we also done with GraalVM, which is not really explored, or is not, I mean, maybe people heard about that, maybe they haven't, but usually people are more excited about GraalVM, about the native mode. But GraalVM is also a polyglot VM, right? So GraalVM allows you to run not only Java, but also allows you to run other languages. So including R, Python, Ruby, JavaScript, right? So remember when I told you that we have that data scientists that wanted to build things in Python and R? Well, GraalVM seemed to be the perfect choice to do this, right? So because it will allow us to build our Java stack with Quarkus, and since GraalVM allows to interpolate between languages, then we could just easily call an R script or a Python script from our Java code directly using GraalVM. So that's what we ended up doing, and it's actually working very fine. So I'm also going to show a couple of demos on how to do that. At least you have that idea. And then a smaller footprint. So one of the things that you expect about Quarkus is, and this is all coming a little bit into details on how Quarkus internal works, is if you compare it about traditional frameworks, and when we're talking traditional frameworks, I'm saying framework for that you've probably been developing for the last 10 years, like Spring Boot. Now Spring, of course, they are doing a few different things and trying to change how they behave. But now let's just say Spring from the last 2 or 3 years, right? And if you pick, for instance, Java E or Jakarta servers like Wildfly or WebSphere, right? So all of these frameworks or all of these platforms, all of them were they will just basically scan the class path for your application, right? And then they'll do a lot of reflection code. They will just instantiate a lot of stuff when you're building, or actually when you're bootstrapping your application. And that's usually why you get so many or a huge amount of startup time on your app, because they have to scan the entire class path and then you have to create a lot of stuff, right? So and reflection calls in the JVM, they are pretty slow. So one of the things that Quarkus have done is they look into the application at build time, and instead of doing things reflectively and on runtime, they will just generate the code directly on compile time, meaning that when you're starting your Quarkus application, it's going to be super fast, because there is no scan path, there is no class path scanning happening, there is no reflection calls happening, there is no bytecode enhancement or manipulation happening, there is no dynamic class loading happening, right? And those are the same reasons why then you're able to build it to native, because while native, of course, does support some of those features, for instance, dynamic class loading is not really supported, right? Because when you're building a native application, you're working in a closed source environment or a closed view of your application, so you cannot dynamically load stuff. So if you're trying to build Java applications with GraalVM maybe 2 or 3 years ago, it was very and you wanted to build them as native, it was very limited the things that you could do. But with Quarkus, now you're able to build full-blown stack applications using Hibernate, using JAX-RS, and then build them as native because of all that work that is being done by Quarkus at compile time, so you don't have to worry about that on runtime. So even when you're running Quarkus as a VM mode, so just as a single Java process, it's going to use less resources, both in memory and CPU, and also startup time, because it doesn't have to go for the entire work that other frameworks have to perform when they're starting up. So So of course, Spring, I know they're doing some work to be able to do these as well. And then, of course, you have other frameworks like Micronaut that's also doing that. So Quarkus is not the only one doing that, but at least you get the idea how that works.
Did we lose him? I think we did. Yeah, I think he's can you guys hear me? Can you hear me, Matthew? Okay, yeah, he must have lost connection. And okay, let's see if he comes back soon. Yeah, I'm not seeing him waiting in the waiting room, guys. So I don't know. Let's see if we can give him another 5 minutes or so. Maybe he's completely lost his connection. Shame, I was enjoying that.
Bunch, and then click my name, and then say
okay.
give me co-host.
Okay. Yeah. Okay. Or make host. Yeah. There you go.
Wonderful. Okay, so I was actually going to show some demos now. I'm not sure in which. So I'm just gonna probably forget about that, but I'm not sure which slide. What was the last slide that you have seen?
So it was the slide. It was that slide. Yeah.
This one.
Yeah.
Okay. So yeah, I was going. So very quick. I was going to show some of the architecture that we pick up to use on these applications that we're also gonna demo, and the one that we develop. So the idea here is you have a couple of services. All of them, they have their own data store, and then they both push and pull events from the message event bus. So something very simple. And the stack that we used for doing that was like REST, MicroProfile, RabbitMQ, and Camel. It could have been Kafka. In the meanwhile, we didn't use Kafka because the company was using RabbitMQ, but I know that they're actually migrating to Kafka in the last few months. All of these were being deployed in using Docker and Kubernetes on Amazon EC2, and of course using S3 for data storage. I have demos to show things running on Docker and Kubernetes. I don't have anything to run on EC2 and S3, but I'm not sure. I don't think that that's relevant for today. So on MicroProfile, we're using things like CDI, JAX-RS, JSONB. Of course, those are the building blocks to develop any REST endpoint. But then we're using other things like config, lcheck, JOT for security, OpenAPI for documentation, and REST client to call the services, of course. Then on the RabbitMQ and Camel side, we're using Camel because Camel has a lot of connectors which is really easy to route inputs and outputs around, which was very convenient for us. All of these, of course, were using async events between the services, which allows it to produce and consume the data that we require. All of these, of course, in persistent data stores, which allow us to rebuild the executions or the inputs and outputs if required. An interesting thing, which was when I was talking about having some data scientists that were doing some of the calculations. So we had a lot of math involved on the application that we're developing. And most of that was being written using R scripts. So one of the things that we ended up doing was we wrap the R scripts using the GraalVM polyglot API. Which allows you to actually call and interpolate languages between each other. So these allow us to call the R script directly from our Java code and remove the need, for instance, to have an agnostic channel like HTTP when you have to do those kind of operations, right? So if you have this team that's writing these R scripts and now you're writing your own code in Java or any other language for that matter, what do you usually do if you want to integrate them? You end up, okay, you expose an endpoint HTTP, I'm gonna call you, and well, yeah, that's fine because HTTP is an agnostic protocol where you can use to transfer data. But of course, there are other implications around HTTP, and it's slow, and you have to put security around it. So this was a very convenient way because it allowed us to run everything on a single VM, and we didn't have to add more complexity of adding more services and adding more HTTP calls in the middle to do this. Okay, so let's go to the demos. So feel free to interrupt me anytime when I was going to do this. So hopefully you can see my ID, right?
Yep.
Okay, wonderful. So all the code I'm going to show, it's on GitHub. So feel free to go there and play with it and use it. So in here, this is a very simple sample, but I have other samples that you can look at as well. So what we have over here is we call like this legum service. And the idea with legum service is the inspiration that we use to build this demo application. Of course, is not the real one that we done on the company. But of course, as you know, if you have any kids, you know that's really hard for kids to eat their vegetables and legumes. So we ended up building an application that produces legumes and then transform those vegetables and legumes in superheroes, because that's an easier way to convince your kids to eat his vegetables, right? If it's eating super broccoli, that's going to give him superpowers, right? So that was some fun way that we were able to do it. So if you look into the code itself, and then I'm going to just run this in a sec. So it has a JPA entity, just one legum, and of course it takes a name and description. Of course, I'm not going to go into. I didn't want to overload this with a huge data model, but you can add whatever data model you want over here, and that's fine. You might notice we're also using Lombok. So Lombok, you can use it directly with Quarkus as well. It works just fine. So if you're not familiar with Lombok, it allows you to add these annotations like builder equals hashcode, artist construction, and it will generate that code for you when you build the application, so you don't have to add it over there. So this is the JPA application, nothing, or the JPA entity, nothing out of the ordinary. And here's our REST endpoint. So one of the things that we actually do, and I think it works very nice, is we do split this into one interface and one implementation, because this allows us to pretty much remove the annotations that you require to add them on the REST endpoint. So if you look into this REST endpoint, it has a post, has a path. So usually when you have the post and the path and the produce, those are just a couple of annotations and you can live with that. But when you start to add annotations for OpenAPI, for you to document the application, right? So this really gets out of hand really quick, right? So it becomes way more, it becomes more annotations than actually codes, right? So one of the things that you can do is you can just extract all of that into an interface, and then you just work with the implementation, and you don't have to look into those annotations all the time. So in here, we'll just add the transactional annotations, and that's pretty much it. And to implement the post, right? When you're adding a post, you want to send a response status created, and then pass the entity that you got posted, and that of course is the one that's going to do the merge on the data store. So nothing out of the ordinary over here. One thing that you might also see is on our post endpoint, which is right here, right? So it does take a different object. So it's like legum new, and there is one for the data source. So in here, it's just a separation between DTO for the REST endpoint and the one that's going to database. So also we think that works very, very well. So you don't expose the database directly to the REST endpoint. So this is just standard things. In here, we have a couple of health checks that we implemented to make sure that our app is up, our app is up. So this works very nice with Kubernetes, because then you can expose them directly, and then Kubernetes is going to call these endpoints on health check, and then only if everything passes is going to add your application to the Kubernetes load balancer and expose it as a pod. So that works very nice as well. And So in this particular case, what we're going to do is we have this application, has a REST endpoint. I'm able to create these vegetables, and then every time I create a vegetable, I'm going to this legume. I'm just going to create a message, and I'm going to post that into RabbitMQ. Then I'm going to have another service that's going to read that and going to transform that into a superhero. So let me, yeah. So here's the message. The message sender is going to be injected right here, and this is just a Camel context. So just create a producer template from Camel. So as you can see, just integrates quite nicely with Camel. Just have to put the Camel context over there, and so there is just some setup here for Camel to set up the RabbitMQ configuration. So this just set up the Camel route and where RabbitMQ is running. And here there is like the message producer for RabbitMQ with password and the address is going to call. And here is the route ID, the message, and what's going to be sent over there. So nothing, and this is the message sender, right? So it's going to actually call that route and pick up the legume and send it over there. Okay, so that's, let me increase the font here a little bit. Can you read that?
Yeah.
Okay, wonderful. Okay, so the first thing I'm going to do is I'm going to start a Docker Compose that's going to create a database and a RabbitMQ for me. So this is just the infrastructure for the application that's going to run. So I'm not going to focus too much on that. And now here's my legume service. So one of the ways that I can run this, of course, is you can use a Java jar target. So actually, let me build that first. So should do clean. Let's just do ambient verify. So remember, I'm not sure if you, I think you still caught that up. Remember when I told you that Quarkus does a lot of stuff at build time, so it doesn't waste things, doesn't waste time on runtime. So the magic actually happens with the Quarkus plugin. So let me also show that. So where, okay. So on the POM file, you'll see there is a Quarkus. Oops. Okay, apparently my idea just crashed. Great. Okay, here we go. Okay, full screen. Okay. So you'll see that there is a plugin that every Quarkus application needs to execute to do the build of all the Quarkus code, and that's going to be used on the application. So then the app actually starts faster and doesn't have to do all that reflection code, all that bytecode manipulation that happens on all the other libraries that we used to use a few years ago, right? Also, one thing, since we're here on the POM, let me also show you something. So as you probably see, all the dependencies that I use are coming from a group called io.quarkus. And so you have Quarkus from REST Easy, Quarkus JUnit 5, Quarkus Hibernate, Quarkus Swagger. So these might be strange, right? So why isn't Quarkus using the actual Hibernate library, right? So that's one of the tricks of Quarkus as well. So one of the reasons why Quarkus is as fast is Quarkus has to implement extensions around the libraries that it uses. So it doesn't mean that the library won't work with Quarkus. So every Java library will just work with Quarkus, but these extensions are required if you want to build this into native mode, right? Because as I mentioned earlier, native mode has a lot of restrictions that usually our libraries don't care about. So what we do as an extension on that library is we work around that and we remove all the things that the native image is not capable of supporting to be able to actually run Hibernate or REST Easy or some other library into native. Now, what you have to think about this is any Java library will work with Quarkus just fine in Java mode, but it may not work in native mode for that reason. So let me just, I'm going to run a couple, a few samples in Java mode and another in a couple of ones in native mode. So run in Java mode. So I build the application, and of course, if you go to target on Maven, you'll see there is a runner.jar. So if I do Java, let me just clear that up. So java.jar and target this legum and start that up. So you see it was like super fast. So you started in like 2.7 seconds. And I'm running Zoom, which you know that takes a lot of CPU. So probably if I'm not running Zoom, it will be a little bit faster. But anyway, my application is running, so that's fine. And I'm going to go over here and I'm going to post a couple of records over there. So that's a banana. We can post broccoli as well. That's fine. And let me query that. So now we'll see those are the objects that I put it over there. So if I go now to, I'm gonna have go to my database over here. So let me show you what's on the database right now. Okay. So let me select that one. And now you see those are some of the records that I added. So let me add one more just to make sure that this is actually working. Okay, so let's add pineapple. Okay, so there we go. So nothing really out of the ordinary, right? So an interesting thing about on the code is look into the sources. So look into the imports. There is no Quarkus imports here, right? So I wrote this REST API, no Quarkus imports. I wrote these API or these REST endpoint implementation. There are no Quarkus imports, right? So actually, let me do something. So if I go here and do a find by Quarkus, yeah, there is only one Quarkus import over here, which is used to do an on-startup event, because I want to start up these Camel routes when Quarkus starts up. But other than that, I'm using standard stuff. So and probably most of you already recognize a lot of the libraries and the classes that were being used right here. So this is, which is quite interesting, that you can develop an application like that and you don't even know that you're using Quarkus. Okay, so I'll go to application properties later. So now let me show you the other service. So the other one is pretty much the same. So the only difference is it doesn't have a REST endpoint. What it does also has a Camel route. Let me just improve this a little bit. So this is the definition again. So nothing out of the ordinary. And what it does is just it's going to consume the event coming from Camel, from RabbitMQ, and then it's going to transform that entity into a super vegetable or super hero vegetable, whatever. And then it's going to store it again into another table into the database. So I'll let me run that one as well. So of course I can do that like that, and it's gonna, oops, not that one. I can rule the Java jar and target hero service.runner.jar, but I'm not gonna do that. So I actually have here, if you see, a binary image of the service, which is called runner, which is 72 meg. And now I'm gonna do something that you should never do, which is I'm gonna cut that file, and hopefully that's not gonna crash. But okay, so now you believe me that's a binary file, right? Okay, so let me run that like that. So how do you run binary files? You run it like that, right? So I'm gonna run this hero service runner. Oops, so it crashes because I have to run it in a different port. So you can pass configuration like any other JVM. So Quarkus 8081, and there you go, boom. It's already started. So now you'll see, actually started in 80 milliseconds. So I'm gonna do that again. You might not even see that. So again, boom, already up. And yes, this is an application that's running Hibernate. It's running Camel, and it's running some other libraries that's running in a completely native mode, which is quite nice. So on my first execution, you'll see that actually it generated some logs. So basically, just picked up everything that was on RabbitMQ and generated the superheroes for that. So now if I come here to IntelliJ again, and if I go and say, where's the console? Okay, select. Sorry, the zooms was blocking my, let me see, but I need to go. Okay, this is in full screen, so when it's full screen, I'm not able to see anything. Okay. Okay, so let's go to the database again. There you go. And if I go hero, okay, so sorry. So actually, when I started the service again, it actually deleted all the records, which is not what we want. But let me post a few here again. So now you'll see that at least you'll see that the record is going to show up there, and then you'll see that I was creating super pineapples, and now what the service has done was to remove that and push them to the database again. So in here, to do a conclusion on how these services are working. So I'm pushing a payload of the vegetable or the legume to one of the REST endpoints. It's going to push to RabbitMQ messaging, and then the other service is going to pull that one. It's going to transform it and then pull it again, push it again to a database, to a different table. So in this particular case, I'm using the same database, but just to save some resources. But of course, the idea is that each service will have its own database. Now, one of the things that I've talked about was that Quarkus was really developer friendly. So one of the things that I want to show you here is, so I'm going to kill that one. And instead of running a Java jar, I'm going to run this in development mode, right? So you can use Quarkus plugin to run this as Quarkus column dev, and it's going to run the exact same way. It's just going to run it as what we call development mode. And what is development mode? So development mode allows you to change your code directly on your IDE and refresh the changes directly on the server without having to restart the server and without having to wait until something to compile and to see something happening. So let me actually show you how that works. So let's see. So I have here my REST endpoint, right? So it's calling HTTP localhost / legumes, but I say, oh, this is not legumes that I want to call this. I want to call this something else. So I can come here to my code. Let me come over here to my API, and I want to call these vegetables, right? So if I go to my, so I haven't done anything, right? So I just went to the IDE, changed that particular line, and I'm going to call the same REST endpoint again. So look what happened, say 404, right? So Quarkus actually restarted or actually rebooted my application straight away, and see it's done the reload in just 0.5 seconds, so it's hardly noticeable. And now if I go to my REST endpoint again, I can go and call, instead of legumes, I'm going to call vegetables, right? And there you go. That's the application is running again, right? And this is just not with pads. So pads might be a very simple use case, but I can come here and do whatever I want. I can create a new method, right? So I have this list. So let me just add a new list, and let's say this list is gonna answer in new list, right? So I don't want to have, so this is an interface. So let's have a new list, of course. Now this implementation does not have that new list. So I'm gonna have to implement that. There you go. So this is returning a list of legumes. So let's return a list off. I'm not sure if I have Java JDK 11 here. Maybe not. List off. Okay. New legum. ID 1, name pineapple, and a description. Doesn't really matter. So apparently this is not using, so let's do collections, singleton list. That will work. Okay, so new list. Okay, let's clear that out. And this one, of course, doesn't work because now I'm vegetables. So if I do this, this is the one that's on database. So now database is empty, and that's what I call like new list, right? Okay, there it is. So that was the one that I just added, right? So see how productive Quarkus is, because I can just come here and change whatever I want on the code, and I can see the changes coming directly. I don't have to stop and restart my application, right? So, of course, this is not the way that I recommend for you guys to develop. Of course, you want to have tests. If you go here and look into the tests, there are tests for the application. But it's a very interesting feature for you to use if you just want to try something very quick, or if you want to prototype something very quick. You can do it that way. Okay, so this clears the dev mode, and we already showed the native mode as well. So I'm going to show you the R service now. So on the R service, is going to be straightforward as well, I believe. So in here we have a very simple REST endpoint again, and so this is just calling a calculator. And now you'll see this calculator have a few operations like add, subtract, multiply, divide, doesn't really matter. And you'll see that this calculator R_add has the function that's being called execute that gives the parameter from the REST endpoint to invoke that particular operation. So let's look on the calculator R. So on the calculator R, what we have over here is, so if you look into the imports, it's using the GraalVM polyglot API to start up an R context. We pass in some of the sources that we found. I'm going to show those sources. So this is just boilerplate code to load that. And then we will just call context.evalve on the source. So basically it's going to do that to compile that R script. Then to execute that script, we'll just call function.execute, passing the arguments, and then you just cast them as they want. So of course, you need to know what's coming from the R script to be able to cast it, but it's not really a big deal. And then on the resources, you have plain R script. So these are just the calculator functions, right? So adding, multiplying, but basically these are just R scripts that are being read over here, and then you just call them directly. So to them on that, so that I'm just gonna run Quarkus again on these particulars, so I'm just gonna kill the other ones. So again, running, this is running in VM mode, so that's the difference between VM modes and native mode. So on VM mode, everything that is still Java, everything is going to work just fine. So this started very quick again, so in 30 milliseconds. Well, actually, that was Camel, sorry. So it started in 1.5 seconds over here. And now I can just do, for instance, I have here calculator subtract, and it's going to take a few seconds at start because it has to start the R context, which takes a while. But after it gets started, it just becomes like a regular service. It's very, very quick. So you don't really notice what's going on, and like that, you're able to call any script written. Well, in this particular case, it's an R script, but it can be JavaScript, it can be Python, it can be Ruby, directly from your Java code. And the interesting thing is, since everything is on the same VM, the objects are exactly the same. So it's not kind of like there is no serialization or deserialization involved. So the objects are actually the same, coming from R or from Java, between both languages. Okay, and the last demo that I want to show you is, so I'm gonna kill all of that. Okay, so this is on another project, but the one that I'm going to show you here is I'm gonna do this build. So it's building this project called Servers Number API. It's building with Verify, and then I'm passing in these additional properties, which is called Quarkus Container Image Build and Quarkus Kubernetes Deploy True. So what actually these two parameters do is it will generate a Docker image and deploys the Docker image into my Kubernetes cluster running locally. So, and that's done. So with a single Maven command with the Quarkus plugin, it already runs everything, build the Docker image, and it's being deployed on Kubernetes. So so if I do kubectl and get deployments, now you see that I deployed something called Number API. It's still not available. It's still what to get services. So Number API is on load balancer. So get services, deployment, like that, and pods. Okay, so that pod is ready, and so I can just call a number to generate. So this is just a service that generates random numbers for IDs. Doesn't really matter. But what I wanted to show you over here is in a very, very easy way, with just a couple of commands, I was able to generate the Docker image. So if I do Docker images here, so yeah, I have a bunch of them, but you'll see that the one probably should be one. It's this one right here. It was generated by that command, and then it was pushed to Kubernetes really, really easy in a single command. Do you have any questions regarding demos? No? Okay.
I got one quick question actually, Roberto.
Sure.
sorry, you did a bit of a demo of using Quarkus dev mode and also the sort of integration with Kubernetes. Have you found a good way of kind of marrying the two? I sort of am typically deploying to a local Kubernetes stack, and although that iteration is quite fast, it's nowhere near as fast as the sort of dev and the response. I'd quite like to sort of marry those two things together, and I haven't found a good way of doing it yet.
You mean be able to deploy Quarkus running in dev mode in Kubernetes?
Yeah, so you can do it. So I have like a Dockerfile dev where I run like the Marvin build in Kubernetes, but then you know, it effectively has to download all the libraries and build the thing in Kubernetes, and then you can get started on doing some sort of debugging on port 5005 or something. But it just feels like as soon as you make the move to Kubernetes, you lose all that benefit that you get from like the instantaneous refresh in Quarkus dev. I just wondered if there was any quicker way of doing it, or that's just a choice. You either dev locally and get the speed or not.
Well, there is one.
Okay.
I've seen other people using it. I never done it myself, but I can have a look into that, and then I can come to you later to see to show you how that's done. But I know that's definitely possible.
Okay.
There is some tricks that you can have that you have to use on the Docker image itself to be able to save some of that time, especially using jitter and probably scaffold as well to be able to do that.
Okay, all right, thank you. Useful.
Any more questions from anyone?
Okay, so if you don't have any more questions for now, I'm just gonna do like the last part of the slides, which basically are the conclusions about the experience that we had with Quarkus when we were developing all of these, right? And of course, if you have any questions, you can do them in the end again. So a couple of challenges that we have when we are doing the adoption story is, of course, we completely started from scratch. So we ended up wasting a lot of time because we didn't even have an infra, and a lot of the stuff were not even Quarkus related. So we ended up spending way more time than we usually do. But I don't think that was on Quarkus itself. Now, when we started using Quarkus, I believe it was version 0.1 something, so it was not even a 1.0 final. Of course, we found many bugs. But again, the community was very quick to fix them, and yes, we were frustrated at some points where upgrading sometimes broke stuff, and maybe you still experience that. So but at that time, again, Quarkus didn't have final releases. Now Quarkus is on a roadmap with final releases, which has way more careful with what breaks or not, and Quarkus does release RCs that you can try them to make sure that we're not breaking anything. So hopefully, I won't just promise that the things are not going to break, especially because there might be a good reason for Quarkus to break stuff, and that might mean that we're doing it to improve something. But if that ever happens to you, so please come to the mailing list or come to the to GitHub, and we'll discuss it. But yes, at that time, it was a way more. It was a time where things were getting break way more often than it is right now. So some shortcomings, of course, of what Quarkus is. There are some CDI limitations, right? So CDI does a lot of reflective and does a lot of dynamic stuff. So for instance, Quarkus does not support portable extensions on some CDI features that are really hard to implement on a closest world view environment that we want to support with the native images. But I believe that we only have one particular feature that we're using from CVI, and I think it was related with producers, extending producers and stereotypes. That was not completely supported, but we always found other ways to use CVI to be able to do what we want. So unless you want to do a really strange thing, the current support that Quarkus has should be enough for you. So building a native image is slow. So you have seen that when I started native image, it was super fast, but the trade-off is that the build is slow. So if you have people over here that build things in C or C++, you know how slow that is. And basically, it's very similar what you're doing over here. But for us, I don't think that's really an issue because these days everyone has their continuous integration environments, right? So you definitely can use the Java mode or the JVM mode to develop and run things in a machine, and then on the CI you can just build a native image and run that. Or you can even run nodes, multiple nodes, one's in native, another one's in JVM. So the experience should be exactly the same. So I wouldn't say there are not bugs between one and the other. Of course, that might happen. But right now, the idea is that the experience should be exactly the same between the JVM mode and the native mode. A couple of things that I already explained is some libraries may not work in native mode, especially if they're using, again, there is no JVM when running native. So some feature is not going to be available, and that's what Quarkus does when they provide their extensions, is to make sure that the features are implemented in a way that are able to run on native. So if you're using any library that's not in Quarkus, it doesn't mean they're not able to use it. It's always going to work fine in VM mode, but it may not work in native mode. And if that's the case, then what you'll have to do is you have to go and implement the Quarkus extension to support that particular library in native. Okay, so are you locked into Quarkus if you want to do something else? Well, I don't really so. Remember when I was showing you the code that you were not able to find Quarkus packages or Quarkus imports or Quarkus APIs? So they're really, everything that I used was really standard, right? There are just a few things that are that might get you locked into Quarkus. One is the application.properties that I haven't showed, but let me show you very quick. So application properties is just a file, kind of like you have in Spring, right? Where it just set it the configuration. But I mean, it's very easy to just move these to some other place. There is this annotation called Quarkus test, and this allows you to bootstrap Quarkus runtime to run with tests. So I haven't covered that part, but to show you really quick. So in here, if I show you here this test, right? So you just call Quarkus test, and then it's just a plain JUnit 5 test that's using REST assured, and you can invoke REST endpoints. You can access your CDI beans. So let me see if I have here one test that injects stuff, so you can see it. Maybe not. It doesn't really matter, but the test you're able to if you can pick up your beans and you can pick whatever bean you want and you use that inject, that will work just fine. And you can test things directly over here as well. So those are quite convenient. So there are the specific Maven artifacts for Quarkus. And again, I explained that those are required for native. But I mean, I don't think that's a big deal. So those are just hidden in the Maven POMs. You'll still lock into the Java EE MicroProfile world and some other libraries that you'll use. But if you want to move to something else, I mean, it's way more easy than if you go to things like Dropwizard or Legume or even Spring Boot. Now, some of the cool stuff that I think that when you're starting, it's really cool. So, well, you have a single jar with just your code when you're doing the runner. So that's particularly interesting when you're doing Docker images, because that means that you only have a single layer that you have to copy when you're building the Docker image, which makes the Docker image builds way faster and deploys way faster as well. So you don't have to copy all a jar with 200 megs with all the stuff. You just copy the exact the code that you just wrote, right? The live reload, so that's the demo that I just showed. So there are a couple of things out of the box. So all the configuration, so you're able to override configuration environment variables, system properties, which is quite convenient when you're running stuff in Kubernetes as well. So you can use the config maps from Kubernetes to override stuff. There are coarse filters, there is flyway support, which we're using. So most of the times, every time that I build a new application, I have to implement a coarse filter. So at least now there is a coarse filter coming up from a framework that I can use. And documentation, I think it's quite nice. I mean, I wouldn't say that's perfect, but if you go to Quarkus.io, right? So you'll see where Quarkus is, and then you have a bunch of guides that you can follow. So for instance, if I want to learn about Quarkus configuration, I can say configure an application, and there is it's going to tell me what do I have to include on my app, the API that's required to use the configuration. So I think that's pretty interesting. So performance, I believe performance does seem better, especially considering the startup time. I haven't showed the memory usage, but I can definitely show it. But I do have some tables to show that in the next slide. So for us, it was very interesting because we were able to save cloud cost in multiple things. So CPU usage when the application was running, less memory, and especially startup time. So before we had applications that were starting in like 20 or 30 seconds. If you multiply that for like I don't know like 500 nodes, it's gonna be a huge chunk of time that you're paying where your application is doing anything. And we're able to shut that off by I don't know starting in like 2 or 3. So of course that's relevant if you now have an application running on 500 nodes, just going to take 2 or 3 seconds to start. So it's less that you're going to pay for your cloud usage. So in the end, your company's going to be happy because you save them a bunch of money. So these are some of the performance values that I have. So using that ping endpoint GitHub project. If you're interested on this GitHub project, they have comparisons with Micronauts, Spring Boot, and other frameworks. I just didn't include them here because I only want to focus on Quarkus, and I didn't want to go into a war between other frameworks. But in here, at least you have a pretty good rough idea. So for instance, on JVM mode, you're going to have more memory usage and going to have a larger startup time. But it's going to be better on throughput, right? So JVM is still going to be better for long-running processes because they're able to automate stuff on runtime, which native mode is not able to do that as well. This is not related to Quarkus, it's mostly on GraalVM side, but I know that the GraalVM team is working hard to be able to improve the throughput on native images as a whole, not only for Quarkus. I mean, this is not this is on the GraalVM side, not Quarkus side. So again, these are some demos that we have, but I do recommend that you test them yourselves. So one interesting thing that you can see about those numbers is, yes, I have less throughput, latency is a little bit higher, but I can definitely, with the same resources that I will use on JVM mode, I can have more nodes using native, and maybe that compensates. But you need to do the math yourself. So do you think that Quarkus is production ready? I mean, I think everything that's new, you have to use it at your own risk, but at least Quarkus now, it's already final for a few months. when we were running these in production, it was not final yet. There are other companies that are running Quarkus in production, and they're just fine. So if you're stuck on VM mode, you should have no issues. Native mode is still, you might still, I won't say it's on early stages because it works just as well. But I will say to test it before going straight ahead with native to make sure that everything is fine. So some of the final thoughts, I think for the company, it was working just fine. It's a well-known stack. So the interesting thing about this is that we didn't have to retrain the developers to use Quarkus because all of the libraries, all the frameworks are already there that they've been using for the last 5-10 years. Everything is still growing. Sorry. Sorry, my kid just arrived. He's yeah, he's a cake. Yeah. I'm just finishing, right? Sorry about that. And yeah, so just give it a try and see how that works. Okay, he wants to say hi. Hey, Lucas, say hi. Diz olá. Okay. Olá.
Hola.
And yeah, I mean, that's everything that I had for you today. So I'm not sure if you have any questions right now.
I think there's one question, Roberto, about from David, and he's asked about if there's any issues with our compilation because it says it's experimental on the Graal website. Apparently, it's marked as experimental.
Yeah. So R it is marked as experimental on Graal. What it means is to make sure that the R ecosystem, they have a lot of libraries that you can use, right? So when they say they're experimental, it's because they don't how to say this? So they don't guarantee that all the libraries on R are going to work, right? Because you're able to go in and install R packages in GraalVM. But the ones that we were using, which were the ones that are the more standard ones, they were just fine. So, and as far as I know, as long as you're using things like, I can't remember the library names, but if you're using the most standard stuff from R, you should be fine. Does that help?
Yeah, yep. So I think David's happy with that. Thank you. So I've got two more questions come up. So yeah. From Andre, just out of curiosity, do you know the examples of Quarkus applications for Internet of Things?
Sorry, can you repeat the question?
Out of curiosity, do you know any examples of Quarkus applications for the Internet of Things world?
Oh, Internet of Things? No, I don't. Maybe they are, but I don't have anyone at this time. I can try to look them up.
There you go, Andre. Short and sweet. I think that's it. So yeah, Roberto, thank you for that. I think we all really enjoyed that, despite our initial technical issues.
Yeah, really sorry about that. And I mean, if you have any, so on that slide you see the link for the slides and the link for the code that I just showed, or you can go to my. So that's actually my colleague. That was the one that I showed earlier. If you go, let me open another one. So you can find, so on this one, which is called Roberto Cortez / MicroProfile samples, this is just using everything that's related to MicroProfile. So it uses Quarkus with all of these specifications and tries to put a sample of all of these. So you can also have a look into that. And that was the one that I used to deploy to Kubernetes. Well, I was going to say that, yeah, feel free to reach me out after the session tomorrow, next week, next month. So if you come to an issue, if you have any problem, I'll be happy to help. Even if you don't have any questions right now, you might have them in the future, so I'll be here to help.
Okay, thank you, Roberto. All right, guys, thank you for participating, and enjoy the rest of your evenings.